Chapter 1. Cause of Cold and Mild Periods. It is now generally conceded by those who have given the subject much attention that the greater portion of North America above the latitude of 39 degrees north to the shores of the Arctic Ocean has been furrowed and scoured by the action of ice. Vast traces of ancient glaciers are also found in Europe, for it is reported that the ice sheets have left unmistakable marks on having overrun the greater part of the lands lying between the Arctic seas and the latitude of the Pyrenees. In Asia, it evidences of glacial action, and it's been noticed from northern Siberia to the mountains of Syria. The great glaciers of Himalaya have in times past attained gigantic proportions. In northern China, huge boulders are found scattered all over the valleys and a long distance from the mountains. The southern hemisphere, in proportion to the extent of its land surface, shows ample traces of former ice action. From the latitude of 38 degrees south to the southern extremity of the western continent, there is said to be the clearest evidence of former glacial action in numerous boulders scattered over the land. Of the shores of the South Pacific, from the island of Chiloe to Cape Horn, the coast is fringed with deep fjords, which appear to be channeled out by ice, like the fjords of Norway and Greenland. And at this date, the mountains of that southern region are covered with snow, and the glaciers which flow down the valleys are said to reach the tidewater as far north as the latitude of 47 degrees south. The glaciers of New Zealand, now of alpine proportions, during the Ice Age descended to the sea, and channeled the deep fjords on its southwestern coast, and certain traces of glacial action have been observed in southern Australia and also in the province of Natal, South Africa. Kerguelen land is pierced with deep, narrow fjords, which have the appearance of having been the work of ancient glaciers. The lands south of the Antarctic Circle are today supposed to be covered by an ice sheet, of which the great ice barrier surrounding that region furnishes ample proof. While impressed with the above reports of the work and the ancient glaciers, in connection with my own observations along the shores of several oceans, I have been led to seek for the physical causes which brought about the great climatic changes of past geological ages. And while having the subject under consideration, I have had my attention directed to the manner in which the great prevailing winds, in connection with continental lands, are able to move the heated surface waters of the tropical oceans into the colder zones, and also transfer the cold waters of the higher latitudes into the tropical zones. And it is through this grand movement of the ocean waters that we are enabled to account for the difference in the temperature of places now lying in the same parallels of latitude. The natural methods for conveying tropical heat into the higher latitudes, and also for excluding it therefrom, are so simple and efficient that on due consideration we are able to conceive how epochs possessing mild climates have been succeeded by periods of frigidity. It has been admitted by several writers on climatic changes that should the tropical surface waters of the ocean be moved into the high latitudes in large volume, thus adding their warmth to the heat imparted by the sun, such combined heat would cause a mild climate, and it has been estimated that the amount of equatorial heat moved into the temperate and polar regions of the northern hemisphere by the Gulf Stream alone is equal to 1/4 of all the heat received from the sun by the North Atlantic from the Tropic of Cancer to the Arctic Circle. Still, it appears to me, while viewing the subject from a marine standpoint, that the explainers of climatic changes have never fully comprehended the manner in which the surface waters of the ocean are moved from the tropics into the high altitudes, and returned from the high altitudes to the tropics. Consequently, they have neglected necessary and efficient natural agents in their explanatory theories, and with much learning and ingenuity have laboriously sought to show how great changes of climate could be brought about through other causes. But when we notice the simple methods employed by nature today for transferring the heat of the tropics into the higher latitudes, and also the manner of excluding such heat therefrom, they appear to afford an explanation for the great changes of climate which have taken place during the past ages. For it appears that the natural manner of proceeding by which heat is moved from the torrid zone into the higher latitudes sufficient to cause a mild climate is through the ocean currents which are constantly set in motion by the great prevailing winds of the globe. These winds, as is well known, blow mostly from the east toward the west in the tropics, and from the west toward the east in the high latitudes. This counter-movement of the winds, in connection with the continent extending both northward and southward from the equator over many degrees of latitude, such as obtains on the western continent, is abundantly able to create extensive depressions and elevations on the ocean's surface, and thus cause vast streams of water to move by gravity from the high sea levels to the low sea levels, and in this way the tropical waters have moved during past ages, and to a considerable extent are now moved far into the northern and southern seas. The transfer of the ocean waters is the main cause of a temperate climate being enjoyed by countries situated in the high latitudes of this age. But in order that the tropical currents should be able to flow into the high latitudes in quantity sufficient to cause all lands and seas situated in such latitudes to enjoy a mild climate, it would be unnecessary that the land should extend unbroken, or nearly so, from the Arctic to the Antarctic circles. Thus, with a continent of such vast extent, the westerly winds would blow the surface waters of the ocean away from the eastern shores in the high latitudes, and so cause extensive low sea levels, while the easterly winds of the torrid zone would heap the surface waters of the ocean against the eastern tropical shores of the continent. Consequently, the warm waters of the tropical high sea level would be moved by gravity to the low sea levels of the high latitudes, even to the Arctic and the Antarctic regions, and thus afford them a mild climate. In this way, we account for the mild climate enjoyed on lands and seas within the high latitudes during the warm epochs anterior to the glacial periods. As the western continent is the only land that extends unbroken from the equator to the cold latitudes of both hemispheres, thus affording an opportunity for the prevailing winds to move the tropical waters into the high latitudes, I will call attention to that portion of the continent which extends far southward into the Southern Ocean, where the winds and ocean currents have the greatest range and power to affect the climate on different parts of the globe. Here we see South America separated from the Antarctic continent by a wide channel of deep water, where the westerly winds blow with great force. The space now covered by this interesting channel, owing to its being situated in the high southern latitudes, must have been occupied by a channel of comparatively small capacity, or else an isthmus of low land uniting the southern portion of South America with the Antarctic continent during the warm epochs when the beds of the ancient seas of the northern hemisphere contained a considerable portion of water now swelling the Southern Ocean. Therefore, the obstructions which separated the Pacific Ocean from the South Atlantic furnished opportunity for the westerly winds to force the surface waters of the sea away from the leeward side of such obstructions, causing a vast low sea level, sufficient to attract the tropical waters heaped against Brazil by the trade winds into the southern seas in adequate quantity to cause a mild climate throughout the Antarctic regions through long periods of time. Recent discoveries have proved that these high southern latitudes have been subject to great changes of climate. According to the reports from the Dundee whalers, while searching for seal in the icy seas that surround the South Shetlands, they met with the Norwegian ship 𝐥𝐢𝐤𝐤, Captain Larsen, who had traced the eastern shore of Graham Land to 68 degrees south latitude, noting 2 active volcanoes. The same mariner brought the Seymour Island fossil shells and coniferous wood of the Tertiary epoch. These furnish sufficient evidence to show that a warmer climate once prevailed there. At the commencement of the glacial age, the obstructions which separated the South Pacific from the South Atlantic had become deeply submerged by the sea, which may have been caused by a tendency of the ocean's waters to move southward or by a comparative small movement in the Earth's crust. But on account of the stability of the crust of the Earth during times so late as the glacial epochs, the submergence of this southern region was probably owing to the movement of the ocean's waters from the northern hemisphere into the southern hemisphere, which appears to have been brought about by through agency of the great prevailing winds, for it seems to have happened that the prevailing winds, on account of the disposition of the lands and seas, were able to move more of the ocean waters southward than they moved northward during the age preceding the glacial periods. The waters thus slowly and gradually forced into the high southern latitudes must have deprived the northern hemisphere of their heaviness and added to their weight to the southern hemisphere. Therefore, the waters moved southward could not all be returned to the seas of the northern hemisphere by gravity, for the reason that the Earth's center of attraction would change in accordance with the weight of water moved from the northern hemisphere into the southern. It will thus be seen that, while the northern seas were drained or became shallow, the augmented southern ocean deeply submerged by the region south of Cape Horn, thus widely separating the western continent from the Antarctic lands. Although the southeast trade winds on the eastern sides of the Atlantic and Pacific Oceans extend further northward than the northeast trade winds extend southward, owing to the heated tropical shores north of the equator being more extensive than such land south of the equator, still, on account of the general weakness of the southeast trade winds at the equator, and also because of the obstructing northern lands, they have during remote times and at this age been largely prevented from impelling the surface waters of the sea into the northern latitudes in opposition to the brisk northeast trades. Furthermore, on account of the widening of the oceans as they extend southward, the surface currents setting in the latter direction have more broad and easy passages than the great currents setting northward. Moreover, the great currents setting southward on the western sides of the oceans south of the equator are also much assisted during the southern summer months by the strong northeastern monsoons, which prevail along the east coast of equatorial Africa and the east coast of South America as far as the latitude of 30 degrees south. The South African current is impelled northward by the trade winds down the southwestern coast of Africa, but it is debarred from entering the northern latitudes by the Guinea currents, and so turned away into the south equatorial current, which flows into the Brazilian stream. The Gulf Stream is much obstructed in its northern movement by the narrow Florida Channel and the opposing Arctic currents, and also by the trend of the North American coast eastward, while its return current on the eastern side of the Atlantic has a much less obstructed passage in its southern movement, and while on its way to pass the Azores and Madeira Islands, it is largely assisted by the prevailing winds. The Brazil current, with the impelling force of a north-east monsoon during the summer season, has no obstruction whatever in its southern passage until it meets with an offshoot from the great drift current of the Southern Ocean, and the same favourable conditions are obtained by the great currents setting southward on the western sides of the southern Pacific, while on their way to the low sea levels of southern Australia and New Zealand. That portion of the equatorial stream of the Pacific which continues west, the Indian Ocean finds no open passage to the northern seas. Consequently, it turns south along the east coast of Africa into the southern seas. Therefore, this current, in connection with the great current setting southward east of Australia, offsets the great Humboldt current setting north along the sea and the coast of Peru. In the North Pacific, the Japanese current setting northward is obstructed by the narrowing of the ocean, while its return current on the American side has a constantly widening ocean on its passage southward, and also favourable winds to impel the surface waters toward the equator. Still, with all the facilities above mentioned for the movement of the ocean waters into the southern latitudes, it is probable that since the shallow seas of the northern hemisphere were drained, or much diminished, the prevailing winds have not possessed sufficient force to further augment the southern seas, because of the superior weight of the land in the northern hemisphere compared with the land south of the equator. It will appear to those who attribute the rotation of the earth as being the main cause of ocean currents, that I am too much given over to the wind theory. But I have reason to believe, as Dr. Kroll has asserted, that the winds are the principal cause of the ocean currents, and are not due to the trade winds alone, but to the general impulse of the prevailing winds of the globe. Dr. Kroll also declares that all the principal currents of the globe are moving in the exact direction which they ought to move, assuming the winds to be the sole impelling cause. Those who think that the rotation of the earth is the real cause of the movement of the great surface currents of the sea should explain in some reasonable way why the 𝐥𝐤𝐤 current turns west into the Atlantic from the Mozambique stream, and why the Guinea current turns to the east from the main tropical current of the North Atlantic. For it seems that these two great currents move in directions opposite to the rotation theory, while at the same time many things go to show that they receive their motion from the winds. These views of the question will receive further attention in succeeding pages. It is the opinion of some writers that a difference in temperature and density between the waters of the polar latitudes and the torrid zone is the principal cause of the movement of the surface waters of the ocean from the equatorial latitudes toward the polar seas, and so returned in undercurrents, and this is a favourable factor for assisting the winds on some parts of the seas, especially in aiding the Brazil current in moving the surface waters from the high sea levels abreast Brazil and the equatorial calm belt of the Atlantic into the Southern Ocean, and also for favouring the surface currents setting southward on the western sides of the South Pacific and Indian Oceans. Yet, whatever gravitating force it may possess for the assistance of the above-named currents, it would also act against the impelling force of the trade winds, while they were drifting the surface waters northward toward the equator on the eastern sides of the several oceans, and also to retard the returning surface currents, while being drifted by the winds southward on the eastern sides of the North Atlantic and North Pacific. Therefore, while it would seem to favour the winds in their work on the one hand, it would act as an opposing agent on the other parts of the ocean Still, the difference in temperature between the tropical and Antarctic seas probably does act in opposition to the wide and brisk trade winds on the eastern sides of the great oceans south of the equator, and so prevents their impelling the surface waters northward to a great extent. And this seems to be one great cause of there being less water moved northward than southward over the greatest oceans of the globe. The theory that the difference of density caused by the difference of temperature between the polar seas and the equatorial oceans made undercurrents to flow from the polar latitudes and meet in the equatorial seas can only be carried on in the Atlantic Ocean, and in a comparatively less perfect way in the Pacific Ocean, and not at all in the Indian Ocean. The North Atlantic being open to the Arctic Ocean, a portion of the Gulf Stream waters that enter it from the northwest of Europe do sink and return southward in undercurrents, and the cold waters which pass down the east and west coast of Greenland also sink under the Gulf Stream while on their southern movement. The meeting of these Arctic currents with the cold undercurrents from the Antarctic seas in the tropical zone is probably one cause of their cold waters rising near the surface of the sea in the torrid latitudes of the Atlantic, and the same conditions probably obtain in a somewhat less degree in the Pacific Ocean. Yet it appears that the cold waters of the Antarctic occupy the largest space in the tropical zone, even in the North Atlantic. Dr. Carpenter, in his lectures on ocean currents, speaks of meeting with the Antarctic water so far north as the latitudes of the West India Islands, and he also says that all of the Pacific Ocean at its depths is supplied from the Antarctic Ocean, as are the cold underwaters of the tropical Indian Ocean, which extend over 20 degrees north of the equator. Thus, from what we can learn of the Antarctic undercurrents, they seem to show that they are not wholly attracted northward on account of the difference of temperature between the Antarctic and the tropical oceans, but partly because of the more surface water being moved southward by the prevailing winds than they are able to move northward. And that concludes tonight's readings. I hope you are feeling a little drowsy. If you're still awake, please feel free to listen to another episode. In the meantime, I look forward to bringing you a new episode very soon, and good night.